In chapter 16, question 3, the question says, what is the overall charge of a non-polar amino acid at a pH below its pI? Okay, so let's talk about what a pI is. So remember, an amino acid is a molecule that has both an amine, so you have this carbon in the center that the two functional groups are going to come off of. You have an amine on one side, an amine, nitrogen has 3 bonds, and then you have a carboxylic acid on the other. That's in every amino acid. Also, every amino acid has a hydrogen, at least one hydrogen coming off of the middle carbon, and what makes them different is an R group. That second thing coming off of that middle carbon is different in all the amino acids, and that's what makes things like phenylalanine be different from glycine, for example. Okay, notice though that in this molecule we have two dynamic functional groups. The amine is a base, and the carboxylic acid is an acid. And so when you put this molecule into water, both of those functional groups are going to change. Remember that a base accepts H pluses. And so when you put an amino acid into water, this basic functional group here, the nitrogen, takes those electrons and uses it to glue a new hydrogen with its plus charge onto it. So that is your new group there. And an acid donates, donates H pluses. And specifically, we've seen that it donates that H plus. So it loses the H and it loses the plus charge. Now it has a minus charge, and this is the new group that you have there. And that's what happens at a neutral pH. This is at, say, pH 7, right in the middle of the scale. Notice that overall, you have one plus charge, one minus charge. If you add them up, the overall charge is 0. You have equal amounts of positive and negative charge, equal electric charges. Now the Greek prefix for equal is iso, and we said we have equal amounts of the two electric charges, so this is called the isoelectric point. And the pH where this happens is to refer to the isoelectric point, the pH at which you have both a positive charge on the nitrogen and one negative charge on the oxygen, is the pI. So the pI is the pH that gives an overall charge of 0 on an amino acid. Now, as the pH changes, it will either slap hydrogens on or rip hydrogens off of that molecule. So let's say the pH gets really, really low. So say below the pI. If the pH gets really, really low, that means the solution is acidic, which means the solution wants to donate H pluses. The solution will stick H pluses anywhere where they can go. And so where can it stick on this molecule? It can stick an H plus on that negative oxygen. And that's why you have the H there. So below the pI, you stick a bunch of H pluses on, and the overall charge on the molecule is positive. Okay, now let's think about above the pI. If you're above the pI, if the pH is above the pI, then that means the solution is really basic, high pH, pH higher than 7. So the solution is basic. That means the solution wants to rip hydrogens off of any molecules in it. And where can this solution rip hydrogens off? This nitrogen. The nitrogen has a lot of hydrogens on it. The solution, if the solution is basic, above the pi, then it can rip one of those hydrogens off, and that's why you see that above the pi, the nitrogen only has 2 hydrogens, whereas at the isoelectric point, it has 3. Notice that above the pi, the overall charge is negative. So, here's our little rule. Below the pi, the overall charge is positive. Above the pi, the overall charge is negative. And at the pi, the overall charge is 0. Okay, so now we can go back to the question. The question says, what is the overall charge of a nonpolar amino acid at a pH below its pi? Below its pi, the overall charge is positive.